Alright, so I'm going to be talking a bit about a paper that I've just read related to a framework which is going to help us discover the best sites for producing hydrogen. This is an IEEE paper that came out early in 2025, and essentially the paper is about augmenting traditional ways of deciding on these types of locations with GIS spatial data and using an analytical, hierarchical, fuzzy matching framework to make a calculated decision on the best place. The main differential of this paper with other prior work is integration of spatial or GIS data in the decision making, and it hopes to reduce the capex and optimize the costs for people who follow this algorithm and use it to prioritize what the best places for hydrogen production are. And we know obviously that hydrogen energy is a new booming type of fossil fuel replacement. Now, the algorithm in question starts with defining the objectives and criteria that we want in our fuzzy match algorithm. So in this context, we have environmental factors, we have offshore wind production, we've got human factors, we've got wind speed and other things. The next thing we do is take all of the factors in question and we essentially assign a weighted priority to each of the factors. So are we most concerned about the economics of it? Are we most concerned about how much wind there'd be, the bathymetry, substations, all of that? So those are all assigned some priorities. We then obtain something called the relative priority vector, which is essentially a sort of an aggregation of all the various priorities. So as you can see here, they've got the same set of factors transposed, and they are basically essentially decomposing the set of factors into a single value, which gives the overall weighted priority that we need to provide to that particular factor. These are then used in the final ranking along with some other calculations, which determine how consistent those factors should be in taken into account for the ultimate discovery of the right location and the rankings of them. Additionally, the paper provides some formulas which help us understand the capital expenditures and the operating expenditures that are associated with operating and starting off these hydrogen plants. So for example, you can see in this formula that the capex related to the hydrogen plant is directly proportional to the amount of turbine power, to the amount of depth of water in that particular plant. It is also proportional to the distance between the offshore wind complexes and substations and the offshore wind complex power in megawatts. So these are all very much significant factors, and you can see here that they have some coefficients which are denoted by C1 through to C11, and these are all parts of the priority. Another set of formulas that they have is related to the cost. So you can see that they've provided us some formulas related to the cost of certain elements, for example, cost of the electrolyzer and cost of the electrolyzer system, set of things like, for example, connection and sealing and other certain things. And you can see here that they're really trying to establish the things which are proportional to these costs and which are not. And you can see that there are a variety of factors and things which are considered here: electrolyzers, nominal rate of flow of water, power, etc. And the paper really just tries to provide all these formulas so that we can put them together in a Python script, calculate the related things, and come to a conclusion in conjunction with GIS data. It also mentions the presence of 4 or so databases of information which are put together to fuzzy match the decision. Now, my take on this paper is that it's a brilliant paper, and the authors suggested that they use a Python script to calculate these things. They also applied the formulas, etc., to the case of Brazil and identifying appropriate locations in Brazil for creating these plants. My particular take on this would be that to productionize or create a product based on this paper, you would need to transform from a Python script to a UI which has a backend, maybe potentially using Fast API, which performs these calculations. I would want to have the GIS database probably as a graph database, or as appropriate, maybe using Neo4j to store all the GIS data in question. I would use Kafka, which is an open source streaming network, to pull together maybe GIS records and other things which I would need, and I would improve on the fuzzy matching algorithm. So here we used fuzzy matching to basically, in conjunction with priorities, to sort of determine what's the best. Maybe instead we want to use weighted neurons or ML models instead. And how this could be taken to production is it could be sold to an appropriate clientele who might be looking for this information, and we could offer, capex estimates, how much you'd save by going here instead of there. And if you wanted to have a continuously evolving value add, then we could evolve this priority model not just to calculate weightages and things which are best just for the hydrogen plant in question, but also for other stages of the plant. Like, for example, various stages of the construction, we might suggest what are the best values or what are the best things to do, best solutions to certain challenges and predictions, etc. So yeah, that was all for my slide for today. I hope that was a bit interesting, and I have a link to the paper below. It's an open source paper, and yeah, catch up soon.